And so one technique that we can use is counting back. Okay? If you start at $1 in the first example and count the money back, I'm just going to borrow your dollars here, and count back to the other person, starting at 1 and going 2, 3, 4, 5, that person then knows that they have the right change. Now this actual principle of counting back actually has its roots in very ancient history. And I'm going to call Wabi now to give us a little history lesson on math and even where the origins of counting back change come from, deep in our past. Is it possible to put the screen up and the lights on here? They'll need the white.
Wally, can you hold this? I don't know what's wrong with the stand.
And like, come on the camera, I can see straight through.
Solve the problem. We can see all that. Okay. I just want to explain. Is this? First, I have a question. Do you know what's this?
It's Arabic.
And what's this?
Roman, well, Arabic numbers.
Which one Arabic numbers?
They're both.
Actually, this is what Arabian people use now, but actually these Indian numbers. And Western people use Arabic numbers. This is Arabic number, and this is Indian. And how they account, or why they use Arabic numbers, because they have a problem with account. How they count numbers like this. How many angles do we have here? Actually, one we have here. And we have 2. And we have 3. Same thing with 4. And 5 and 6. And how they, let's say, 2 plus minus 1. They start from right to left. So we lost one angle here, so we have just one angle. This is very, very simple. Arabic lesson.
And to add is very simple too. 2 plus 3.
Oh, 2,
Yeah.
2 plus 3, and until we have 9. At that time, around 2,000 years, we don't have any problem with numbers. And they figure out they have problem with after 9. So they discovered there is a number without any angle, which is 0. So 1 without means 10, and 11, 12, and so on.
Thank you. So using our denominations actually relies heavily on this concept of 0. Okay? And so what you can see, I want you to pick a more complex example. And I want partner B to give all their money to partner A for this next example. Okay? So you have lots of change. Just for now. I get it all back in the end. And we can see how we can incorporate that example of the 0 now. And so when you're counting back, when you're counting up and not doing the math in your head, if you hit a 5, then at the end, you know that you can move to the next increment or denomination of the $5 bill. When you hit one that ends ends with 0, you know you can move to one of the denominations that ends in 10, 20, 50, and then on up to 100 and 500. I want you to use that technique now, counting back with your partner, and I'm going to give you a more complex number. Partner B wants change from partner A for $700, and the amount is $432. Okay? So partner B has given partner A $700, and they would like to change $432. So $432 from $700. And I would like you to use the technique of counting back. So start at 432, and you're going to count up to 700.
80, or 75, 80, 90.
How much change? You're supposed to buy
getting
something for $430. You're gonna pay her $700 for something that costs $432. So, okay, so you're going to pay your partner $700 for something that costs $432, and your partner is gonna give you the appropriate change.
Okay, so I'll give you 700.
Well, that's why I said you can just pretend you gave the 700 and just make the change back.
So I will give you 500.
Yeah.
Okay.
Partner, your partner gave you the $700, now make the change that's required for something that costs $432. Try using the count back method.
35, 40, 50.
This is why students love accounting.
Cyril has a question for us.
50.
How the compound method relates. That's an interesting story about how the numbers are,
Okay, and then 2 here.
have the different angles, but I don't get how that connects with
You're
counting back.
basically doing the same thing
Okay.
as you are with the angles.
So easy.
The concept is the same, right? So basically what you end up with here, in a way you're just using ones here, right? And you're counting back up. But it's basically you're counting how many angles you need until you get to 5, right? So you need 4 angles. So this is working at the opposite direction. It's basically what you're doing here when you're using that for subtraction. Okay? But the concepts are the same. It's the number of angles in each increment. Okay? So the number of ones in a $5 bill are 5. 5 angles. So we've got our 5. $5 bill has 5 angles. Okay? When we add the 0, okay, we'll have 10 angles, 20 angles, 30 angles, 300, 100 angles, 200 angles, 300 angles. Counting back is a simplified way.
I'm surprised.
Just breaking it down into angles. Okay? So, how did you make out? Did everybody get the correct change? Okay, let's start. For those of you that have the change, let's count back now. From 432, we'll take our $1 bills, 433, 434, 435. Everybody got a 5 for 50. Okay. What if some of you still have 5s? Oh, some of you still have 5s. So then you have to use the 5s to continue counting.
That's for 40 though.
That's for 40. Then this is 50.
Right. Did everybody have to use the exact same bills to make the change?
No, but you're taught in retail to use the least number.
The least number of bills. So it does take a bit of a skill. But the first thing I would want a retail clerk to is to give me the correct change. Next, I would like the finance of the least number of bills. All right, let's call on Deborah, and she's gonna talk to us a bit and get a bit of your feedback and ask you a few questions.
Try
on
not to
this
use up the
exercise.
space.
Okay, so this part won't take very long, but what we wanted to ask you is, why do you think it's important to know this? Or do you think it's important to know this, how to make change? So I don't know if